G'day guys, in today's video we'll be talking about zeros of polynomials. We've got an example right here. It says, we've given us a polynomial right here, p of z equals to z cubed minus 7z squared plus 25z minus 39. It says, given p of z has 1, 0, 2 plus 3i, write its three factors. So, to start up, we need to understand the conjugate root theorem, which will help us do this question. What is the conjugate root theorem? It says that if a polynomial has real coefficients, then we know that p of x plus iy, so let's just say p of x plus iy equals to 0, and it's got real coefficients. We should then know that p of x minus iy is also going to equal to 0. So whenever any polynomial has real coefficients, you need to know that it's going to have conjugate pairs of complex zeros. Right here. So if we've got 2 plus 3i, let's just get on to the example now. We know that its conjugate is also going to be a 0. So 2 plus 3i is number 1. The second one is 2 minus 3i. Finding the third zero, we can use sum of roots to go about this. So alpha plus 2 plus 3i plus 2 minus 3i equals to minus b upon a. So minus 7 upon 1 is just 7. 3i chop. We get alpha plus 4 equals to 7. Alpha equals to 3. Lining up as its three factors, we know that this then equals to z minus 3. P of z equals to z minus 3. First factor. Second factor is this one right here. So we go z minus 2 minus 3i, and then the last one is z minus 2 plus 3i. So relatively straightforward question, but just to get our head around the conjugate root theorem. So yeah. So now, looking at this next example, little bit different, but let's see what it says. So it says, solve p of z, given that it has a real root of multiplicity of 2. So they've given us a hint that there's going to be multiple zeros in this question right here. So the first thing I will do whenever there's like questions that include a multiplicity of 2 or whatever number that is I'll take the first derivative of p of z. So given, let's just say p dash of z would then be differentiated. So we've got 4z cubed minus 18z squared plus 28z plus 28z minus 30. So we've gotten p of z and we've got p dash z. Looking at this, the real root that we're here to find is going to be a factor of both 45 and 30. So what are some factors of 45 and 30? We can quickly just do a little LCM method. Well, 45, 30, 5, 9, 6, 3, 2, 1, 3, 2. So these are our three factors we're going to use. So these are the three factors of 45 and 30. So we have z equals to plus minus 1, plus minus 3, plus minus 5. Correct? Now we're going to individually substitute these values into the differentiated version and see which one of these gives me a value of 0. So we can go p dash of, we'll start with 1. 4 minus 18 is negative 14, plus 28 is 14 minus 30. So negative 16, nope, not our answer. P dash of negative 1 gives me negative 4 minus negative 18, negative 22, minus negative 28 is going to give me negative 22, 30, 42, negative 50 minus negative 80. Nope. Not our answer. P dash of 3 gives me, put it in my calculator. I did it earlier. Gives me 0. So P dash of 3 gives me 0. So that's what we were looking for. Now we're going to sub in 3 into P of Z. So we sub it into P dash of Z and we got 0. Sub it into that. So P of 3 then equals to, let's do it right now. 3 to the power of 4 minus 6 cubed plus 14 squared minus 30 plus 45 also gives me 0. So P of 3 also gives me 0. Therefore, we know that the multiplicity of 2, so the multiple zeros, is going to be Z minus 3. So let's rewrite this. P of Z then equals to Z minus 3 squared multiplied by Z squared plus B of Z plus C. Obviously we're going to use these two constants because we don't know what they are. For now, aim is to try and find those two. Expand this, so we get Z squared minus 6Z plus 9, Z squared plus B of Z plus C. 9C, we should know that needs to equal to 45 to find the value of C. So we go 9C equals to 45, C then equals to 5. We figure out what the value of C is, write it down. Z squared minus 6Z plus 9, Z squared plus B of Z plus 5. Correct? Looking at this now, so to equate the value of B, we need to find the coefficients of Z in this case. So coming back here, we'll rewrite this over here. So we've gotten Z squared minus 6Z plus 9 equal, brackets. We've got Z squared plus B of Z plus 5 equals to this right here. It'll be Z to the power of 4 minus 6Z cubed plus 14Z squared minus 30Z plus 45. So we know that negative 30 plus 9b equals to negative 30. 9b equals to 0. So b therefore then equals to 0. So the value of b would then equal to 0. So let me just quickly write it up here. So 0. So b then, which then gives me 0. We can now simplify this further. So P of Z then equals to Z minus 3 all squared, brackets Z squared plus 5. So that is what P of Z gives me. So looking at this now, next step would be, we know that P of Z equals to 0. So then, if that equals to 0, we know then Z equals to 3, Z equals to root 5i, or z equals to minus root 5i. So these are the three solutions, or the three zeros that we're going to get for z if we fully solve it like we've done here. So yeah.